All right. Well, I am excited to welcome to Test and Measurement Forum Dr. Sameh Yamany, who is one of my favorite people to talk to when I am looking for a good read on trends and latest developments in test. And he's going to be talking with us about leveraging AI and digital twins for validating and optimizing networks. And given VIAVI is one of the folks at the forefront of this, I'm really excited to hear what he has to say. So Dr. Yamany, please go ahead.
Thanks, Kelly, and thank you for having me here. I mean, it's an exciting time right now. I think even we're listening to the last sessions, the complexity of testing and complexity of the network right now is going up. And Chris from AT&T in the last session, he was talking about it's complexity going up. We don't have that enough people actually to manage this complexity. The same thing Greg was saying that. And it's that's I think is the time where we are seeing huge development in the industry right now, leveraging AI and this concept of digital twin that actually can improve that. And let me give you a little bit of my perspective, because in VIAVI we do like four different things, when we talk about test and measurements. So the idea is not just looking at a single point in optimizing the network, because it starts from the beginning, from when you're trying just to bring in a new technology. Think about the lab testing. That's the first thing. Vendors and operators, they start thinking, okay, I have this new technology, I have this complexity, I need to upgrade. I'm working with vendor X, vendor Y. How I gonna manage that? And it starts in the lab, even though a lot of people say, I don't want to spend too much time in the lab right now. Why? Because lab used to be kind of using synthetic data. You're using some kind of what is the standard, but you're not mimicking what we're seeing in the field. So that's why I think AI and digital twin is changing even the fundamental here, because you look at the lab and you're saying, okay, I'm gonna try to emulate some scenarios. I'm gonna do, here is 5G NSA, is 5G SA now. We're thinking about, okay, is 5G advanced and open RAN, how the interaction between, the RF, the X hole, the front hole, all these applications that's gonna come on the rig. And you start emulating this in the lab. But here AI comes in and changes the dynamics a little bit, because there are a lot of test cases sometimes that you see it in the field. So bringing field information into the lab so that you can actually start generating scenarios that as close as possible to realities. You start building machine learning for training on real traffic, right? Not just synthetic traffic, real, problems with interference that you can actually mimic in the lab. So you get more confidence before you go into the field. And here is also where AI plays another very important role. We have been hearing right now, and I saw in the Mobile World Congress, which is amazing, that AI now is taking center stage in a lot of operational capabilities. We're trying to do energy efficiency. We're trying to do some automated work. But how we know that this AI is actually doing the right thing? I mean, that's another complexity that we need to think of. And I think VIAVI is trying to play a game here, because we are the guys who are testing, right? So what is the gold standard when it comes to AI? And here is also, I have this famous say I say in the US, don't go to a gunfight with a knife, right?
Yeah.
If you really want to test what AI is doing, you have to use AI. And this is where, digital twin, building these kind of realistic digital twin that you're actually mimicking a real network using AI that is trained and using, some, agentic AI and generative AI capabilities to mimic a reality, to also mimic, a disaster scenario, and see how the AI that is in the network is going to react to that. So that's one area when you are designing, just looking for upgrades, looking at all of that, how you're going to actually be able to use AI and digital twin.
Okay, can I ask a second here? Because you've got bias meter, drift meter, over under trained meter. So that's very specific to AI. Can you talk a little bit more about what each of
Yes.
those means, and because those are things that telecom testing hasn't necessarily had to look at before.
Yeah, it will be naive to imagine that today we understand how AI is going to be tested, because there is a lot of things that is not yet standardized. We are working with 3GPP on how AI ran and how AI is going to be involved in the next releases. So, but I also say this. One of the fundamental thing about AI is that we know that we'll be biased. I mean, it depends on data. So if you don't govern what the data is that you're using your AI to train, it will by default will be biased. So I'm not saying let's fix this problem, but at least let's be aware of it. Let's build a bias meter. Today, are you more biased than last time or not? Right? Are you more drifting or not, right? Did you overtrain? Did you undertrain? Where did you, I mean, and because we kind of, we sit across global operators around the world. We work with pretty much all the vendors out there. I think we have a good idea how you can measure these kind of biases, how you can measure, at least just measure them. I always say if you don't measure, you can't control. If you don't measure, you can't optimize, right? So that's how we are thinking. There is a new era for testing right now with AI. So moving forward, now you tested in the lab, now you're feeling a little bit confident, but this is not the story. The next story is you're deploying. And I said, coming back from what Chris said in the last session, there are not that many people anymore that have this expertise. In fact, there is a big problem in telecom. Today we call it the disappearing expertise, right? That are, it's becoming more complex, going in and trying to install, building these massive MIMOs or doing this now interoperability and see how it works in the field. That's becoming more complex. And again, here is where you really need to move. Actually, here is we're moving the lab into the field. We're trying to go when you are when deploying, when certifying, how can you generate an environment in the field that can give you confidence that this is meeting what you're looking at, but also meeting the dynamic requirements that's looking at that. And here is another area that we're thinking is going to also have to change. AI is also bringing this expertise that is missing to be assisting. I always say that the best solution right now is that, you're not going to find the same expertise, that the time to train, but can you make it simpler so that the job takes less time, that the job can actually be done by people who can actually get more on the training, where the experts, the field instruments, the field solutions are actually using digital twin in the field. So think about this. These instruments are communicating with a digital twin in the field that is helping during the instrument, that's actually automating a lot of the process. They're also responding as if it's an assistant that is working hand to hand with the technician, deploying, doing interference, something. We did this demo in Mobile World Congress where we showed our CEO actually going and doing interference hunting, right? There was a test, right? Can he do it? And AI was helping him a lot. So that's another area that we are seeing AI and digital twin come to the help of operators and vendors and the industry in general, the ecosystem, to help them make sure that this is fast, quick, and reliable.
It seems like the next step of some of the automation that's been going on in the background in test, I think across the board, and sort of automating these processes, making them repeatable and simplified, and now, taking it to the next step where there's actually some sort of chatbot that can walk you through them.
Absolutely. And I think there is a lot of people say, oh, AI is there is the hype, and we saw it 2 years ago. But honestly, this year I was happy to see AI being actually showing real examples in operations, right? And I think this is now showing maturity in the way people are addressing this. It's not just every have a hammer, then everything is a nail. No, actually, right now there is very well defined solutions for AI, and this is one of the great examples where AI is going to tremendously improve a lot of the reliability and a lot of the automation that people are looking for. Then moving next, okay, so now you're installing it, but the story again is not done. You need to manage, troubleshoot, operate. And again, we have been in the forefront of that. VIAVI has been doing this for decades and helping in operations, monitoring, doing troubleshootings in all different areas, either the RF, fiber, or transport. And now cloud is becoming also an essential part of the operation itself, which brings its all complexity as well. So, mixing cloud assurance with end-to-end assurance. And again, AI has been playing already a role in that in terms of, again, helping in building upgrade scenarios. That's again digital twin. And I'm going to show an example where digital twin can help you, orchestrate the whole upgrade as if you're doing it in the real network before you actually even, change a single software. I mean, we're seeing a lot of these outages that happen just because the software was upgraded. So how, and they tested in the lab. I mean, the reality is it is tested in the lab. It is tested in the vendor lab, but it's not at the scale of running it with all these different scenarios that are only real in the field. So that's again where digital twin becomes an important thing. And with the era that we're moving everything to cloud, it is possible to do that. So this again where also AI plays a very important role, what we call the AI ops, getting a lot of this huge data from operation and trying to understand and intelligently building these kind of digital twin that can actually detect anomaly, that can actually define root cause, and even build rapid responses automatically. Again, helping automating, but also helping manage the complexity of the network. And then, yeah, and then the
Actually,
last thing, yeah, go ahead.
Oh, I'm sorry. I just wanted to say because you're starting to get into some of the digital twin aspects of this, and I think we just kind of had an interesting question come in about gaps and bridges between different digital twins and sort of those relationships and how you actually get and build an end-to-end picture. So I'm wondering if maybe you could take this opportunity to talk a little bit about that.
Absolutely, and here is the reality also. I mean, we were thinking digital. I always say the digital twin is almost like the flight simulator for the net, right? You're trying to, before the pilot goes in and drive this new shiny plane. You have to spend time in the flight simulator. So that's where the digital twin. But in reality, it's not a single shot in time. It's not a static view. It has to be dynamic. So there is a relationship between collecting real data from the field, right? Getting all these probes data, all these traces data, all these instruments data, all these either crowdsourcing data. Bring this from the field in reality, in real time to the digital twin. And this is a continuous. It's not just CI/CD, CI/CD, CT, digital twin, right? You're bringing all of that and adjusting it. There will be some missing data. That's sometimes you're gonna have to manage that. That's why AI is playing a role in here, trying to create as close as possible. But I also say it's not just creating reality; it's also trying to create extra reality. What happens? I mean, we're upgrading a train system with 5G. What happens if there is a hurricane? What happens if there's a storm? Can you emulate this in the digital twin? Again, that's another example where you're taking it to the next step because we really want resiliency here. So you're right. There is a lot of still gaps, but I think the role is bowling in terms of bringing real data. There is so much data out there that some people actually dismiss in a lot of time. Oh, we have so much data, but maybe it's not important for troubleshooting. Maybe it's not as most important, but it's important to train a real digital twin to actually be as much as possible mimicking the real scenarios. And of course, that goes into the next layer, which is optimization. Now we're talking about, I'm done with operation. I just want to, have energy efficiency. I want to have, spectrum efficiency. Again, digital twin and plays an important role in doing what if scenarios. One of the things that we are doing these days is looking, for example, as this whole discussion on NTN. And again, there was a statistic say 96% of operators around the world already have an end-to-end plan, right? So it's not an idea anymore. It's there, but it's challenging. There is so many things. So again, we work with a lot of these LEO satellites. They are using a lot of our tools in their lab testing, but we're also bringing a lot of real data so that we can build an end-to-end digital twin. You want to test, your handover scenarios with Doppler effect. You want to hand direct to device and doing some kind of, what kind of uplink and downlink problems you can see. And you want to test, okay, your solution, not in real, but you're testing it using our digital twin, do channel, modeling and, performance testing using realistic scenarios. Will show you all the different beams that a real NTN is doing, and then you see how your handover works, right? And you can test it in real time against these end-to-end digital twin, right? There was now we are seeing it's not just anymore, looking at telco. We're looking at these private networks, these expansions. We were working with the U.S. agriculture and building this next smart agriculture. Again, digital twin helps you here in terms of emulating interaction, understanding the scale, understanding the problems, testing different innovative RAN technologies using this on the digital twin. We have a big railway, solution that we go in and test in real railway networks. Again, they are upgrading to 5G in Europe and in Asia. They are moving now to a different network. And then again, what if scenarios, using these kind of historical data that we have to actually build these kind of RAM propagation scenarios in, mimicking the real environment. So again, I hope this gives you a little bit of understanding how the trends is moving, what AI and digital twin is doing, and if you have any question, I'm looking forward to them.
Okay. Yes. No, actually, I'm really excited that you brought up the NTN strategy that you are working on, and I'm wondering if you can talk a little bit more about that, because I think we're hearing, and I think we had Sylvia talk a little bit also about the NTN partnerships that are developing, and that's moving this year into tests, trials, beta services. We just had Amazon Kuiper launching their first satellites last night, as a matter of fact. So I'm just curious if you can talk a little bit about VIAVI strategy as you're thinking about those NTN and meeting the challenges there, because that's a really challenging
Right.
RF environment.
It is really challenging, and again, coming from our history of building, RF test solutions that you can actually mimic real interactions with different vendors, with different suppliers, with different environments. I mean, each NTN, each LEO or GEO system is different. There are still a lot of problems. I mean, depending even how you want to design where you put the G not B. Is it just terrestrial, or is it actually up there? I mean, so there is so many scenarios, and there is so many options you want to take. And we're actually gonna do. I'm presenting some of the work we're doing with Singapore and Japan in Osaka Expo in next month. Again, showing some examples. It is still complicated. I will not lie that says we have all the answers right now. That's there's this digital twin is needed. I think right now we are seeing some maturity in terms of where the decision is making. Every country is different, every operator is different. So it's very it's almost very exciting for us to be interacting, because seeing all of that, we learning from the operators, we're learning from the LEO. The requirements is a little bit different than terrestrial network, and now you're going to have to mix it with terrestrial, which bring also the concept of bringing data. We have all these historic data of 5G and 4G. How are you going to use that to see how the interaction between the terrestrial and the non-terrestrial network is going to work? So it's exciting. It's moving along. This is not by far yet done, but it's an evolving industry. Yeah.
Okay, so we still have a couple of minutes. I thought we got a very interesting question from the audience, and that has to do, so when AI is testing AI, how reliable will the results be considering AI hallucinations? So I think this sort of starts to get into some of maybe the unintended consequences, or like at least the risks that have to be thought about when we are starting to really rely on not just automation, but artificial intelligence to
Right.
guide or assist testing. So what are your thoughts there?
Yeah, absolutely. In fact, actually, that's one of the reasons you want kind of independent AI systems, interacting with each other, because, the kind of hallucination happens because you keep almost like a homogeneous kind of approach using the same kind of data. I argue that, if you're testing with a certain kind of phone data that is coming with against a certain device, you know, by default it will be biased that, and then you can start overtraining it, and it starts hallucinating a little bit, providing scenarios that not just not realistic, but it's actually confusing. And that's why you want an independent view. And we in VIAVI try to play this independent view. I think the idea here is, not about the AI. Honestly, it's not about the AI. It's not even about the testing, about the data. And I think this is the shift. We are now even, talking the AI RAN Alliance, who are really pushing forward that. And finally, we come into the point. Don't think about testing in the traditional way, because it's not about, testing all of these kind of scenarios and here are the procedures and here are the standards. It's actually about the data. It's what kind of data you're using, how you get governance over this data, how you get, data ops. Actually, this is a new term that we are trying to use, because that becomes a key point here.
Okay. Wonderful. Well, I think we are out of time for this session. Sameh, thank you so much for the time and the perspective on this. It was lovely to have you. And folks, we are going to be moving into our next session on bandwidth bottlenecks and RF interference.
Thank you, Kay. Thanks, everybody.
Thank you.